So what we're going to be learning about today is really valence and core electrons. We know that so far we've said, hey, the number of protons and the number of electrons should be the same when we have a stable atom of an element, okay? So for example, if we have an atom of oxygen, we know we can look at the atomic number and say, hey, we have 8 protons, so we're going to have 8 electrons because it's stable. Well, why can we use that word stable, or what does that tell us? That means that the number of positive charges and the number of negative charges balance each other out. Okay, so what we're going to do here, we're going to go a little further into electrons because we know that the electrons are outside of the nucleus, but we're going to learn the difference between valence and core electrons, okay? So the shell model is what we'll be focusing on here. And so basically we're going to have a nucleus and then we're going to have circles, okay, that we will place electrons on outside of the nucleus, okay? The electrons that we will find in the outermost shell of the atom are called the valence electrons. All the other electrons are called the core electrons, okay? The periodic table really likes to reflect, or really likes to show that this is a pattern when we're looking at valence electrons. And we'll refer back to lessons 9 and lessons 10, looking at those cards a little bit when we're looking at the number of spikes or the number of spokes that we have on those atoms. Okay, among those main group elements, so remember that's groups 1, 2, and those are both A's, and you have 3 through 8A as well. Okay, you jump across those transitions. Always remember transitions are not considered main group. But again, among those main group elements in the same group have the same number of valence electrons. Okay, so we know if we're in group 1, where hydrogen is, everything there has 1 valence electron. If we look at the cards, it would have 1 spike. If we're in group 2, we will have 2 valence electrons. If we go over to 3A, okay, or we can also call this group 13, we have 3 valence electrons. All the way over to 18, or group 8A, where we have helium, neon, argon, krypton, those have 8 valence electrons, or we can say that their outer shell is full because helium can only hold up to 2 electrons there. We'll learn that, okay? So the learning goals for this, you're going to be able to create a shell model diagram of an atom, placing the correct number of electrons in the correct shell. So whether you have a valence shell or a core shell, you'll be able to explain the difference between a valence electron and a core electron. You'll be able to describe the patterns in the periodic table associated with electron arrangement. So here we're going to take a Sharpie, and on that periodic table that you had colored, we are going to add numbers to our periodic table, just to kind of, again, be one of the best helpful things there is. Okay, so here's a warm-up question. Take a look at these cards here. This is kind of a little generic knockoff version of the cards that we used for lesson 9 and 10. What did they show us? We have the element's name, the element symbol, and then we have a sphere representing the relative size of the atom, as well as those spikes or spokes coming out of the sides of those atoms. Okay, what do you notice about the number of spokes on the circles? Okay, best thing to do is look everything in the same column. So go from hydrogen, lithium, sodium, potassium, rubidium, all the way down that column. Everything in that column has the same number of spokes. Okay, but if we start at lithium and move from left to right all the way over to neon, we will notice that as we move to the right, we gain another spoke. Okay, some vocabulary terms that we have here. We have valence shell, valence electrons, and core electrons. So your valence shell is your outermost shell. This correlates with the row number, okay, in terms of how many shells we have, okay? So look at your periodic table. Hydrogen is in row 1. How many shells can hydrogen possibly have? Just 1. Okay, lithium is in row 2, so there will be 2 total shells for the electrons of lithium. Sodium is in row 3, or period 3. Sodium will have 3 shells. Okay, one of those will be the valence shell, and the rest we'll consider core. Okay, so what do you mean valence and core? Well, we have valence electrons and core electrons. Okay, the valence electrons are the outermost electrons, and that's what you see represented with those spikes in that previous picture, okay? And then the core electrons are all of the other electrons in the atom other than the valence, okay? So how do we make that make a little sense? Okay. Find magnesium on your periodic table. Okay. Magnesium, it's atomic number 12. Okay. It is in group 2, period 3. Group 2, period 3. So when I say group 2, I have how many valence electrons? You should say to yourself, hey, I have 2 valence electrons. And just learn this brief little bit of information. Okay. I have 2 valence electrons. And if you are in period 3 or row 3, then you should have 3 shells. Okay. So let's look again. The atomic number is 12. And so far, since we're dealing with things that are stable, my number of protons and my number of electrons will be the same. So if I have 12 protons, I have 12 electrons. Well, we've just said that magnesium has 2 valence electrons. If they have a total of 12 and 2 of those are valence, that means we have 10 of them that are core. Okay. All right. So again, take a look at these pictures. You saw these a few lessons ago. This is a picture of a 3D model. That is a picture of a 2D model. You know, the shell, this is what we like to call the shell model. Why is that? Because we see all of those great little circles, and it's basically just showing us kind of the Bohr model of the atom, representing the different distances from the nucleus that these electrons are away. Okay, so again, you see a picture of magnesium down below, and you see also a picture of sodium. Okay, so what's the difference between the 2D model and the 3D model? 2D, everything's flat. Okay, so it kind of appears that everything's a lot closer than probably it really is. Okay, so if we look at sodium, notice you have that dark circle in the center, which represents the nucleus. Okay. Well, how many gray circles do you have around that? Well, I can count 1, 2, 3. Okay, well, let's think about it. What row is sodium in? Sodium's in row 3. Great, so it should have 3 shells. Okay, sodium has 11 total electrons. 11 total electrons. Can you count 11 dots on those shells? Sure. Okay, sodium is in group 1 of the periodic table, so it should have 1 valence electron or 1 electron in the outermost shell. Do you see just 1 in the outermost shell? Sure. Okay. So the atomic number of an element is the same as the total number of electrons that we have. Okay. The number of electrons increases by 1 as the number of protons increases by 1. Okay. The number of electrons will correspond to the atomic number of each element. Okay. The number of electrons really doesn't identify what element we have, but we just know that currently, since we're dealing with stable atoms, protons and electrons, or your positives and negatives, have to balance each other out. Okay. The period, or we also call the row number of the elements, is the same as the number of electron shells. Okay. As we go down the column, okay, and let's say from hydrogen all the way down to francium, you are increasing the number of shells that you have. Okay. If you are in period 2, you have 2 shells. If you're in period 4, you have 4 shells. Okay. For the main group elements, the group number of the element is the same as the number of electrons in the outermost shell. Okay. For example, all group 4A elements, so 4A starts with carbon, have 4 valence electrons. Okay. If you notice, I have written here groups 1A all the way to 8A. Okay. If you have your periodic table numbered 1 through 18, that's totally fine. Okay. That A just designates that it's a main group element. But you'll also notice in parentheses, I have group 3A listed as group 13 or column 13. That starts with boron. Okay. All the way down. I like to tell my students a trick. If your periodic table is numbered 1 through 18, if you just pay attention to whatever number is in the ones place, okay? And that will tell you how many valence electrons you have. The outermost electron shell is referred to as a valence shell. So anything inside is considered core, and we call these core electrons, okay? Chemists really pay attention to the outermost shell because that tells us a lot about how an element will react with other elements, okay? The arrangement of electrons is highly predictable, okay? So things you want to ask yourself, what group number or what is the group or column that this element is in? What is the period that is in? Because if I tell you the name of an element and you ask those two questions, you can give me some really good information about that element, okay? So for example, let's say, okay, tell me about the element sulfur, okay? So first things first, you have to find sulfur on your periodic table, okay? So go ahead and do that. Its symbol should be a capital S, okay? What group is sulfur in on your periodic table? Well, you can either call it 6A or group 16. What does that group number tell us? That group number tells us how many valence electrons we have, okay? So it should have 6 valence electrons, okay? It should have 6 valence electrons. Well, if we have a total of 16 electrons and 6 of those are valence, how many electrons are considered core? You just do some subtraction. I apologize. So 16 minus 6 gives us 10, okay? If you look at the row or the period, you can figure out how many shells that you have. And since this is in period 3, you would have 3 shells. So your outermost shell will have 6 electrons in it, and the inner 2 will share those 10, and we'll learn how those are organized, okay? The number of core electrons also shows us a pattern as we go across each row of the periodic table, and this is something that we will, look at more in depth when we do some practice here. So in the first row, we have absolutely no core electrons. Everything is considered valence. Why? Everything in the first row just has one shell. And if there's one shell, there's nothing on the inside, okay? Everything in the second row, from lithium over to neon, they have 2 core electrons and some number of valence in their second shell, okay? The third row, you have 3 shells, so we have 10 core electrons. 2 come from that first row, 8 come from the second row, okay? The fourth row, or the fourth shell, you have 18 core. 2 from the first, 8 from the second, 8 from the third, okay? We have to cross over those transitions, and then we'll have 28 core. And again, we'll look at this when we do this practice in class. Okay, so just make sure you mark some stuff down. We are going to practice this when you come into the classroom.